I was not disappointed or surprised by the NASA officials' statements. I was truly disappointed by the quality of the image because it was smeared by the jitter and the motion of the camera. Consequently, we cannot truly see much better than before, and in fact the Hubble image was far more informative. We haven't learned anything significantly new today. The presence of hydrogen surrounding the object is not surprising, as water is present, and water can be broken down into hydrogen and hydroxyl molecules. We already have evidence for such molecules from radio observations. Actually, just this morning, one was reported by MERCAT, the radio observatory in South Africa. So, altogether, there was little news, and that's what I was concerned about. After a long delay of 45 days, we didn't learn substantially more. Indeed, the amateur astronomer images we were able to view in recent days were considerably more informative. Moreover, the instruments that took them cost thousands of dollars, not $1 billion like the NASA instruments. Therefore, I would argue that it was largely a discussion by NASA officials about what they expected this object to be, rather than a depiction of what the object truly is. As Sherlock Holmes famously said, an obvious fact is highly deceptive because you are overlooking. I mean, they essentially neglected to mention any of the anomalies, the unusual facts concerning Freya Atlas, such as its enormous mass, 1,000 times smaller than the previous object, yet 1,000,000 times more than the first object, and the fact that it moves in the plane of the planets, which allowed the NASA observatories to see it. That constitutes an unusual coincidence. If you multiply the probabilities for both of these, you get a 1 in 100,000 chance. And topping that off, there is the anomalous composition, including the jets. But the good news is we don't need to wait for NASA to tell us, because a flood of data will become available in the coming weeks, culminating on December 19th, when the object reaches its closest point to Earth. At that time, we will figure out its composition, its velocity, and the quantity of mass being ejected in these jets. Once we know that, we can compare it to what is anticipated from pockets of ice on a rocky surface, and if the findings are vastly different, it could indicate thrusters. The image that you are just showing now has a scale of a fraction of a degree, and that is like 100 million, that is on the order of 100,000 to 1 million kilometers, at a distance of 3 ATLS. It's truly not effectively scrutinizing the nucleus. Consequently, these are very fuzzy images that we received today from NASA. We can't draw many conclusions, but when we look with the largest telescopes on Earth, or with the E-Webb telescope in the weeks ahead, we might actually acquire images with much better resolution than what we have seen previously. Therefore, I will simply remain vigilant for this new data expected in the coming weeks. That is to say, the press conference itself did not genuinely offer us anything noteworthy. When the press conference began, I did what I always do before looking at new data. I set aside all assumptions, all expectations, all theories, and I let the evidence speak for itself. NASA presented images from Hubble, Webb, SphereX, MAVEN, Lucy, MRO, Punch, SH, Psyche, and several other spacecraft. More than 15 missions were involved in observing 3A Atlas, an extraordinary coordination effort by any measure. But as the slides went by, the fuzzy halos, the smudges, the angled tails, the thermal signatures, I waited for the one thing that never came. They did not talk about the size, not even once, not even casually, not even indirectly. And that omission, in my view, was the most remarkable part of the entire event. You see, the size of 3A Atlas isn't just a number. It is the central clue, the anchor point that every other measurement relies on. When you calculate mass loss, dust production, water outgassing, hydrogen halo size, coma brightness, or non-gravitational acceleration, you must know how large the nucleus is. Yet NASA avoided that topic entirely. But based on the data that is available from the Webb telescope, MAVEN's UV halo, MRO's high-rise brightness profile, and the way dust scatters light, it is now clear that 3A Atlas is far larger than typical interstellar objects. Not slightly larger, not moderately larger, but orders of magnitude larger. And that creates an enormous scientific problem. It is important to understand the scale. Borisov, the second interstellar object we detected in 2019, was about 1 kilometer in size, and that already surprised us. Before that, Oumuamua was smaller than a football field. But 3A Atlas, based on the combined constraints from Webb and MAVEN, its nucleus is likely 5 kilometers across and possibly larger. That means it is 1,000 times more massive than Borisov and more than 1,000,000 times more massive than Oumuamua. This is not a small difference.
In astrophysics, when your third observed object is 1,000,000 times more massive than the first, you do not ignore that fact. You stop everything and ask, how is this possible? And that is the question NASA did not ask. In astronomy, we deal with probabilities and distributions. If the universe sends us interstellar objects, we should expect to detect the most common sizes first. Small objects are far more numerous than large ones. Therefore, statistically, we should have detected 1,000 Borisov-sized objects before detecting one Atlas-sized object, and 1,000,000 Oumuamua-sized objects before detecting something this large. But instead, the third interstellar visitor we have ever detected is the largest by a factor of 1,000,000. This is not normal. In fact, it is extremely improbable. Something is off in our models. Either our expectations about interstellar debris are wrong, or 3I Atlas did not form the way we think it did. And both interpretations deserve our full scientific attention. Yet again, this subject was not mentioned at all during NASA's event. What NASA offered were images. Interesting ones, yes, but not definitive. We saw a teardrop-shaped dust cocoon from Hubble, a massive hydrogen halo from MAVEN, faint, indistinct blobs from SH, a smudge with a semicircle from MRO, a sideways tail from Punch, a slight motion deviation in Psyche's tracking back, thermal hotspots from Spherex, early Webb spectrograph dots. But these do not answer the deeper questions. Instead of confronting the most puzzling aspects, the size, the alignment, the nickel anomaly, the jet collimation, the lack of variability with rotation, the presenters remained within a comfortable script. It is a natural comet. It is unusual because it comes from another system. We are seeing features caused by environmental differences. This is, in my opinion, an incomplete scientific approach. The extraordinary size of the object is the first thing that should have been mentioned. Instead, it was not mentioned at all. There is another remarkable fact that NASA skipped over entirely. 3I Atlas arrived on a trajectory aligned almost perfectly with the plane of the planets. This allowed all of NASA's major observatories to observe it continuously. Hubble, Webb, Solo, Lucy, MRO, MAVEN, Punch, even the rovers. But statistically, only 1 in 500 incoming interstellar objects would be aligned like this. It is a rare coincidence, very rare. If you saw a dice land on 6 500 times in a row, you would question the dice, not assume everything is normal. Yet NASA celebrated this coincidence instead of analyzing it. The lack of curiosity concerns me more than the data itself. I want to be clear.
I do not believe NASA is hiding anything intentionally, but I do believe the organization is bureaucratic, and bureaucracies avoid uncertainty. To mention the size is to open the door to the fact that our models of interstellar debris might be fundamentally incomplete. Scientists, however, must embrace such questions. If nature gives us a surprise, the appropriate response is not to sidestep it, but to investigate it. And the size of 3I Atlas is not a minor detail. It is the key to understanding everything else. Let me explain why this is so important. Interstellar comets are expected to form around distant stars, ejected by gravitational interactions and then wander through the galaxy. But it is extremely unlikely for such a process to eject an object this massive. Ejecting a 5-kilometer-wide chunk of ice requires tremendous energy, far greater than typical planetary interactions provide. Either 3I Atlas formed in a rare environment, or it was ejected by an extreme event, a stellar flare, a planetary collision, a tidal disruption in a binary star system, a fragment from a destroyed ice giant. All possibilities, but none smooth or common. This is why the size matters. It tells us about its origin. Yet the origin question was left unasked. Imagine detecting 3 vehicles on a highway. First, a motorcycle, second, a small car, third, an aircraft carrier. Would you call this a natural sequence of random sampling? Or would you ask why the sampling is so biased? This is exactly what has happened with interstellar objects. Oumuamua, the motorcycle, Borisov, the small car, Atlas, the aircraft carrier. A 1 to million-fold jump in mass in just 3 detections should not be ignored, yet NASA ignored it. The reason anomalies matter is simple. Anomalies are the birthplace of discovery. Every major revolution in science began when someone questioned the parts that did not fit. Mercury's orbit, the ultraviolet catastrophe, the photoelectric effect, dark matter evidence, the cosmic microwave background, each emerged from an anomaly. Therefore, ignoring the biggest anomaly of 3I Atlas, its sheer mass, risks missing the most significant insight of this object. The most valuable data has not arrived yet. On December 19th, when it reaches its closest point to Earth, hundreds of telescopes will track it. Hubble, Webb, Keck, VLT, and the Umani, Subaru, Gemini, and dozens of amateur observatories. At that point, we may finally determine the true size, the density, the jet mechanics, the rotation state, the mass loss rate, whether there's non-gravitational acceleration, whether the jets correlate with brightness, whether it fragments, or whether its core is surprisingly solid. That moment will be decisive. Let us assume the simplest interpretation. 3I Atlas is a natural comet. Even then, the size demands explanation.
It implies that the factory that produced it, the star system where it formed, operates very differently from any system we know. Perhaps it had a massive Kuiper belt analog. Perhaps a runaway ice accumulation event. Perhaps a catastrophic planetary impact that ejected enormous icy fragments. If 3I Atlas is natural, it tells us our theories of planetary formation are incomplete. Our expectations of interstellar debris size are incorrect. Our ejection models underestimate the extremes. That is an enormously important discovery, one far more important than a fuzzy image. Another fact NASA did not mention. The nickel-to-iron ratio in 3I Atlas is unlike any comet we have ever observed. Comets in our solar system always contain far more iron than nickel because the iron peak is dominant in stellar nucleosynthesis. Yet 3I Atlas shows the opposite. Nickel without iron is not natural in comets. You only see that in industrial alloys used for aerospace materials. I am not saying 3I Atlas is artificial. I am saying the chemistry, when combined with the size, strongly suggests we are missing something fundamental. If 3I Atlas rotates once every 16 hours, the jets should wobble, twist, or curve, but observations show they are tightly columnated, straight, and stable. That is unusual. Combined with the size anomaly and nickel anomaly, it becomes part of a bigger picture, a picture that NASA did not discuss. I want to emphasize, this is not about dismissing NASA. I respect NASA deeply. This is about encouraging scientific curiosity. If something looks unusual, we must not force it into familiar categories. We must let it teach us what it really is. The size of 3I Atlas is not just an anomaly. It is a clue. And clues, especially extraordinary ones, should guide our questions, not be ignored for convenience. As scientists, we owe the public honesty, not certainty. The truth is simple. We do not fully understand 3I Atlas yet. Its size is unexpected, its chemistry is unexpected, its alignment is unexpected, its jets are unexpected, and its evolution is unexpected. And that is exciting, not frightening, not threatening, exciting, because every time the universe breaks our expectations, it gives us an opportunity to learn something profound. When I look at 3I Atlas, I do not see a threat. I do not see an alien craft. I do not see a doomsday object. I see a question, a rare, beautiful question. And the universe has dropped at our doorstep. And the correct scientific approach, the one I hope we embrace, is to investigate that question with humility, curiosity, and openness. The size matters because it forces us to rethink what is possible. And that, ultimately, is the heart of science.